Question number 56. When electrons in sample of hydrogen atom make transition from fifth excited state to ground state, then the maximum number of spectral lines which belong to visible region is. In this question, we first have to know that if we are talking about visible region, it belongs to Balmer series. The first thing. And one more thing, if we consider the Balmer series, definitely for that, the N1 value is 2. And if we talk about the fifth excited state, let me mark here, we are talking about the transition from fifth excited state to ground state. And in this case, the N2 value can be 6, it can be 5, it can be 4 or 3. So how many total transitions would be there? From 6 to 2, 5 to 2, 4 to 2 and 3 to 2. So total number of transitions in this case would be, I can write here the maximum number of spectral lines. Those can be observed are 4. And if it is so, the option that's correct here is option 2. That is the answer. Now, after this, the next question is here. Question number 57. The number of right-angled bond in BRF5 is. In this particular case, first we have to check the shape of BRF5. And that can be found out with the help of its hybridization. That is sp3 D2. This is the hybridization for this BRF5. Let's draw its structure. Its structure is square pyramidal. So in this case, central atom Br, the fluorine atoms. In this way, one fluorine atom is here and a lone pair is also there. Now, in this case, there is lone pair and bond pair repulsion. Due to which no angle is right angle. And if it is so, the answer is 0 here. That's given in option 3. And I'll write here the correct answer. I hope this question is also clear to you. Let's move on to the next question. Now here's the question number 58. Among the following orbitals, choose the one having maximum number of nodal planes. So in this case, we have to just find out the maximum number of nodal planes. And we should know that the number of nodal planes are always equal to the L value, but except for the Z² orbital. Now, so if we talk about 4d Z², there are 0 nodal planes, because in this case always the nodal planes are 0. Now, the second one, 3d X² minus Y², this orbital we have, the value is here, the L value is 2 here for the d orbital, so the number of nodal planes would be 2. Then we have option 3, 3s, the nodal planes would be 0 because we are talking about the s orbital. Then we have 3p orbital, and for the p value, the value of L is 1. That's why here. Now, on the basis of this, the maximum number of nodal planes would be there for 3d X² minus Y² orbital. That is in option 2. So I'll mark here the correct answer. That is option 2. I hope this question is clear to you. Now let's move on to the next question. Question number 59. An element X has equal number of neutrons as are in 16s32. and has 31 nucleons. The position of element in periodic table is. So first thing that's given here is that element has equal number of neutrons which are present in sulfur, as well as it has total 31 nucleons. So if we talk about the number of neutrons in this, these are 32 minus 16, that is 16. And the total number of nucleons present here are 31. So the number of proton in that given element X is 31 minus 16. Because the total nucleons are 31, nucleons are neutrons and protons. So the protons are here 15. And on that basis, its atomic number is 15. So atomic number is 15. And what would be the electronic configuration? That would be 1s2, 2s2, 2p6, 3s2 and 3p5. We have the electronic configuration. On the basis of atomic number, we can say this element is phosphorus. And the configuration is given here. On the basis of configuration, we can find out the period to which this element belongs. That is third period. And the group to which this element belongs is group 15. Now on this basis, we can choose here the correct option, third period and 15th group. This is given in option 3. So I'll mark it as the correct option. Now after this, we have the next question. Question number 60. Number of bond angles of 109.5 degree approximately in CCl4 molecule is. For this, we have to just see what is the structure of this CCl4 molecule. It is tetrahedral and structure can be drawn as in this way. And if we consider this molecule in space, we will identify that the total bond angles of 109.5 degree in case of CCl4 are 6. So we can mark here the correct answer for this particular question is option 2. I hope this question is clear to you.